Now that we have a grid structure made of frame elements, let's add some floor slabs to our model. We'll write a new create floor slabs function. This function will receive the story number, story heights, and x and y total lengths. First, we'll need some variables for our area object creation. Next, let's define a new object group for our floor slabs. We can do this by using our SAP 2000 model and accessing its group definitions and calling the setGroup function. This function simply receives a name string and creates a new object group if one does not exist with the given name. We can also set a number of other group properties, mostly relating to analysis output, but we won't really use these in this example. Let's call our new group Slab, and we'll assign our created floor slab objects to this group. At this moment, we don't really need to assign the floor slabs to this group, but this will be advantageous in the future. Now, we'll resize our coordinate arrays and set the x and y arrays to the coordinates of our vertices. We can do this now because all floor plans will be the same for every floor, and we simply need to adjust the z-coordinates for every story. This also makes sure that we're using the same coordinate sequence on every floor. That way, we'll guarantee that the normal vector for each floor slab is always pointing upwards so that the reaction values are always consistent. Let's cycle the building stories and set our z-coordinates. You may notice that we are not starting at 0 height and we're actually doing the quote-unquote correct number of cycles as opposed to our previous function. This is because we don't want to create a floor slab on the lowest floor. Okay, now we'll simply call the addByCoordinates function and assign our created area object to the slab group by calling the setGroupAssign and using the return area object name. Lastly, we'll correct the automatically created area section by assigning the C30/37 concrete material to it. Alright, let's declare a couple of variables in our main function to hold the total x and y lengths. For this, we'll also add a new helper function that's very similar to our previous helper functions. This one will sum all values in a column, starting at a cell and going downwards until it finds an empty cell. And now, all we have to do is test our code as usual. Great! Now we have created a model with floor slabs incorporated. Before moving on, we'll divide our slabs via the cookie cut method and we'll set the auto mesh size for our floor slabs. First, the function that uses the cookie cut method. We'll call it divide slabs by cookie cut. For this function, we'll use something new, the selection object. To use the selection object, we need to access the select object from our SAP 2000 model object. Then, we'll use the group function with our slab group that we created earlier. This way, we can select all objects of this group automatically. Then, we need to create a few variables to cycle our selected objects and to divide them by cookie cut. Now, we need to get the number, names, and object types of our selected objects since the function to divide area objects by cookie cuts only takes one object at a time. We'll call the getSelected function using the select object. This will give us the full list of names and types of selected objects as well as their number. Then, we'll cycle our objects using this, and, just as a precaution, we'll check that the object type is an area object by checking that it has a value of 5, before proceeding to divide it. After that, we'll select all objects in the model, and then, we'll divide the specific slab object by cookie cut. We're selecting all objects in the model so that we can divide our slabs using all points and frames in our model. It doesn't matter that the original selection is being overwritten since we already have the names of the slab objects that matter to us. Okay, next let's alter our user form and create a new text box that allows us to input the mesh size for our auto mesh feature. Let's add our text box. Let's also add a place in our worksheet to input the mesh size and format everything correctly. And let's show our template form to format our worksheet and write a mesh size value. Okay, all we need to do now is to create a new simple function to set our auto mesh. We'll call our function setShellAutoMesh, and it's just going to receive our SAP 2000 model and a mesh size value. For this function, we'll use the property area function with the default asec1 area section. What this does, effectively, is select all objects in a model that have this area section property. Next, we'll go to area object in our SAP 2000 model, and we'll use the setAutoMesh function. Now, this function has a lot of arguments, so we should probably look at the documentation. What we really need to look at is the mesh type that we want. This will be type 2, which is to mesh objects to a specified maximum size. The max size 1 and max size 2, which will be our mesh size, the restraints on edge, which we will set to true, and the last parameter, which is the item type that we will set to selected objects. Let's then call our function while relying on the VBA context tips to guide us as to where we are in the parameters. We can also leave most of them blank as most of them are optional. As a closing touch, we'll use the clearSelection function to deselect all selected objects. A lot of functions that alter objects will also deselect them after making changes to them, but, as a precaution, it's best to explicitly deselect them so that our selection does not impact other selections we make further down our code. It's also a good practice to ensure that, when you are selecting objects, no objects are selected when we start using the selection object. Alright, let's call our two new functions and provide our AutoMesh function with the mesh size value we've input into our worksheet previously. And let's run our code once again. So, at a first glance, it looks like nothing has changed. However, if we go to set our display options and then general options, we'll select the option to show analysis model and click OK. Now, we can see that the floor slabs we created have been divided even further into a mesh of elements no bigger than our specified mesh size. This concludes our floor slabs exercise. Next, we'll be adding restraints as well as the option to add basement walls to our model.